attendance. So I'm not taking attendance. I'm telling the university whether people are in class or not. So I need to do this 2 or 3 times, so I'm not going to do this every week for your health and my health. But I do need to go through it. If I mispronounce your name, you can either just shrug or correct me, whichever you choose. It's interesting. I'll give you an example of what foreign exchange markets do and oil prices do. A professor's abilities to pronounce names. So if you're teaching regularly, especially in business schools, you have lots of foreign students, typically. And you can tell over the years what the exchange rates were by which names you get to pronounce really well. So if the exchange rate is such that there are a lot of Thai students, I actually learned how to pronounce those impossible names. And if the euro goes in a particular direction, my French gets better, and so on and so forth. So it actually has these repercussions right down to, these are marketed right down to whether I can pronounce your names or not. The last time, let's see, when was this? This was a long time ago. So the late 80s and the early 90s, oil was really cheap. And it was also a period of time where lots of people came over from the Middle East to go to school. And exchange rates were good and all that. And then in some of my graduate classes, 25% of my students were people from the Middle East. And I got, so I was incredibly good at pronouncing Arabic names, like rattle them on. But you can see how markets work. You see how international markets work, just looking at what happens over time in the classroom, what faces you see. It's changing a bit now, but it's switching some other direction now. We're going to have a lot fewer students if the oil prices from overseas, if the oil prices stay where they are. Just Europe's in trouble, Russia's in trouble, the Middle East is in trouble. We won't have any Texans. It'll just go all the way down. So, attendance. Tiffany, eye type? You here? Asaf Mansour Al-Asaf? Yeah. Is that close? Hayden Al-Friday? Morgan Barton? Amy Bryant? Megan Burkhart?
Here.
Yeah, sorry.
Madam Cook? Evan Delano? Delano Delano? Delano Delano?
Delano.
Delano. Thank you. Madam Dixon?
Here.
Justice Jefferson? Catherine Fleming?
Here. I go by Katie.
Brandon Pope? Katsunori Hoshi?
Here.
Is that right?
Yeah.
Travis King?
Here.
Moses Lynn?
Here.
First name right? Moses?
Yeah, that's right.
Natalie Lucy? Nicholas McDonald?
Here.
Howard Ginn? Mary Nunez?
I go by Haya.
That's why it's nice. And Cody O'Connor?
Here.
Hannah Ostrander?
Here.
Enoch Park? Nicole Reed? Katie Reed Stoller? Russ Donald? Riley Shannon?
Here.
Gary Schumacher?
Here.
Mocker?
Schumacher.
Jaden Stevenson?
Here.
That was here. Got it.
Yeah.
Skylar White Colton? Lucy Wilhelm,
Here.
Riley Wood, Elaine Yang, Gross, Xian Yonami,
Yonami,
and do that again.
Yonami,
That'll take me a while. One more syllable comes out. And first name is Sean.
Shan,
Preston Young. And how many people do not get their name called? So after class, just for safety's sake, put your name on here and your email address. If you haven't gotten, if you're on this list, you should have gotten a syllabus and a couple of readings. If you're not on this list, I'll email them to you later today. So you can have those. What else? So a couple other things that I just mentioned. People always ask me, well, what should I read? Just casually about economics. I read the New York Times, The Economist, and the Wall Street Journal. Two of them every day. And The Economist is a weekly. If you're casually reading stuff and you see an economist lying around in the doctor's office and in somebody's office, steal it. You can keep it for 2 weeks. And it's got lots of stuff in it that's interesting. Occasionally there's an economics article. So the oil article I gave you, it's not from the magazine, the hard copy of the magazine, it's from the online version. So those sorts of things are in there. The Wall Street Journal, if you want to start learning to read the Wall Street Journal, just buy the first section. Read the front page and read the op-ed sections. And that'll sort of start giving you a flavor for what's in there. The money in investing is tedious and unpleasant. Their Saturday fashion magazines are better than the New York Times fashion magazines, but otherwise it's front page and op-ed sections. Section, the first reading you have is pilfered out of Hal Bronner's book, The Worldly Philosophers. It's very good. It's biographies. This sounds like it would be the most boring thing in the world. It's biographies of economists from the 18th and 19th and early 20th centuries. It's extremely well written and sort of gives a really good history of the development of the market system in the world. I usually assign it in macro classes. I assign it in micro classes, but it's another thing for you to get piled onto, so I don't, but it's something worth reading. There are a couple other books I'll tell you about along the way. That one's worth getting and just having around for almost casual reading. So, today's, in some ways, the most unpleasant class you have to deal with, because I'm going to look out as I'm doing this, and I'm going to see a third of you are totally bored to death and going, I don't need this, I don't want to see it, I know how these things work, this is fine. And then those of you that would, you're being business majors because your dad wants you to be a business major, but really what you want to do is be a philosophy or an arts major, and you don't know the darndest thing about graphical analysis, are going to be looking at me in terror. So we'll get the two extremes here. What I'm showing you today, we're going to do two things actually. I'm going to put up some tables that are a little more detailed than you want, and then I'll show you generally what they would look like if you were to graph them. And you might want to go home if you're unfamiliar with them or you're nervous about them and actually graph them. The graphs we end up with are going to be pretty much the foundation for what we do the whole quarter. I'm going to show you some simple, just general Cartesian coordinate systems first, And then I'm going to show you what we look at on the demand side in terms of graphing and where the graphs come from, and the same thing with the cost side. Once you've seen, so I'm going to put up tables, so you know a bunch of numbers that are out there. And except for the day that we actually do demand analysis, start demand analysis, and the day that we start the theory of the firm, I'm never going to put numbers up again. I'm just going to put the graphical pieces up. What I want you to do is get comfortable with the graphs. And you may need to do that with more examples than what I'm going to put up now. So we deal with if you remember that from some high school math course, Cartesian coordinate system. We deal with this part of the Cartesian coordinate system. We don't get into negative numbers, and we don't get into negative quantities yet. We haven't figured out how to do that yet. And so I'm going to put this up, it's a table, and then I'll show you generally how it's graphed. And I'm not going to go into the implications of it at this point. I'm going to do the same thing with the cost piece. You will see these exact tables again when you go through demand and when you go through cost analysis. So we're going to have something called price in dollars and quantity in units. And so in economic parlance, that's demand. It's a bunch of points on a demand curve. And we can do a whole bunch of stuff with it initially. We can talk about something, for lack of a better term, we're going to call this marginal use value. So what a demand curve shows is it shows the relationship between prices and quantities. It shows the units people will buy or a person will buy at various prices. And what you're going to see is there's an inverse relationship between the quantity demanded and price. All that means is if the price goes down, the quantity demanded goes up, and if the price goes up, the quantity demanded goes down. That's what we mean when we're talking about demand curve. We also talk about why this thing looks this way. The basic premise, and there's no science particularly behind it, is that the more you get of something, the less you value an additional one. So the marginal value of an additional one after you already have one starts to fall. Or another way to look at it is assume this is the demand curve for something for this class. And there may be someone in the class that values this thing at $10, and there are 3 people who value it at $8. So their demand curves are reflecting either individual preferences or group preferences. And we can describe something as marginal use value that says, well, the first one's worth $10. The second one's actually worth $9. And so on, 7, 8, 7, 6, 3, 2, 1. So marginal use value and price are the same thing, the way we describe the demand curve. And it's redundant, and there's some redundancy in there, which you'll see why in a second. We have something called total use value. So again, without going into the real technicalities of what it is at this point, total use value is simply the sum of the various marginal use values. So the first person values it at $10, so the total use value in quantities 1 is $10. The second person values it at $9, but the first person still values it at $10, so the total use value is $19. Anybody with me? Yes, sir?
Can you repeat the definition of the total use value?
Total use value is the sum of the marginal use values.
Okay, thank you.
And I guess at some point you're going to need to understand this in this context. What it means is that you're taking everybody's valuation, their maximum valuation of something, and adding it together.
Okay.
Or you're taking an individual's maximum valuation of multiples and adding them together. Okay, and if we did this for the whole string of them on the sheet, so I think 7, 4, so that's total use value. So just as a start. So I'm going to graph this, and I'm going to put this into a unit of time. That's the Q, T next to it over there, in prices in dollars. And if I were to actually graph this thing the way I have it up there, and just showing 10 items, what's it look like? It looks like a staircase. So that's actually how the thing looks. So we're not going to use the staircase generally. We're going to use a straight line that says that it's smoothed out because there's so many of them. But generally, the staircase sort of helps us in a way, at least initially. So if you want to look at total use value, you simply take the sum of things under the staircase. So we know that this is a 10, we know that this is a 9, we know that this is an 8, we know that this is a 7, and so on. And if we just go 10 plus 9 plus 8 plus 7, we get the total use value of 4 items. Okay, or graphically, we get the area under the curve. And as you're going to see, it's the area under the curve we're going to play with. That's going to give us a total value of something or other. And just to make the quick jump, there's that demand curve just smoothed out. I got rid of the little sawtooths. Okay, and if I wanted to say, okay, what's the total use value when there are 4 of them? So at 4, I would simply go, it's the area under the curve. That's all we'd be looking at. Everybody with me so far? Okay. What else can we do with this? We can do this. depending which side of the counter you're on, if you're in a marketplace, and we're gonna assume for now, so you gotta catch this assumption, we're gonna assume that you have a seller out there selling this stuff, and when he does sell a certain number of items, he has to sell them all at the same price. So we'll come back to the other issue that he sells one at one price and one at another price, but for now we're saying, if he sells 4 of them, he's gotta sell them at $7 a piece. So, the firm looks at it as total revenue, the consumer looks at it as total expenditure. They're the same thing. And we end up with 10, 18, 24, 28, 30, 30, 28, 24, 18, and 10. Everybody see where that came from? So what's different about that particular curve relative to a bunch of other curves that we already have up there? What?
Revenue goes up and
Then it goes down. Okay. This is going to turn out to be an important feature here. I just want you to note it at this point. As we move down this demand curve, and under here, total revenues increasing up to a certain point, and then it's decreasing. Okay. And you're going, that's a little weird, but I'll show you how it happens. Well, before we do that, no, that's okay. We'll do one more little curve here. We're going to calculate marginal revenue. So marginal revenue is the change in total revenue. So this is, if the firm's going to lower its price, it's going to change its total revenue. It lowers its price, what's going to happen? Based on our theory, he's going to sell more. But if he lowers his price, he has to lower his price on everything. So he's going to lose on the ones he already sold or would have sold. And he's going to gain because he sold more. So we start with marginal revenue is 10. And then when you go to sell, if you sell 2 of them, you sell them at $9 a piece. So your marginal revenue is 8, and then it's 6, and then it's 4, and then it's 2, and then it's 0, and then it's -2, -4, -6, -8. So your revenue actually gets negative. Your marginal revenue actually gets negative. You're observing this already. You already saw this here. It went from 10 to 18, 18 to 24, 24 to 28, 28 to 30. Then it got flat, no change in revenue. And then revenue actually started to go down. So how do you show that graphically? There's that demand curve. And to get total revenue graphically, you just take total revenue is equal to price times quantity. We've already defined that. So we just take price, here's $7, and here's 4 units. So that's where we are. This point on the curve represents 4 and 7. On the curve, and area of a rectangle, width times height. That's all you're looking at here. Total revenue is represented by that area. Again, all you're doing is you're living in a simple geometric shape. You're looking at price times quantity. If we lower the price down to $5, we get a quantity of 6, and we get, actually, I don't have this drawn exactly, but I should. There it is. 5 and 6, you'd end up here, and this is actually a good example. Let's look up. If we lower the price to $5, you increase the number of goods the guy sells. Okay, everybody okay with that? That's just what the demand curve is telling us is going to happen. But in terms of total revenue, this total revenue goes from this rectangle to this rectangle. He loses this revenue and he gains that revenue. And he's gaining revenue because he's selling more. He's losing revenue because the price is going down. So we're generally speaking always going to be dealing with straight line demand curves. I mean, I'll put up some other ones. And demand curves don't have any particular shape. They could be curved or swirly in some ways. They're always downward sloping. They don't have to be straight lines. But the straight line gives us some clear configuration that we can deal with. And if you look at this carefully, you'll see if you take the demand curve and then you graph instead underneath it the marginal revenue curve. The marginal revenue curve is going to look like that. Okay, so if you have a piece of graph paper and you graph the stuff, that's what it's going to look like. But you don't need a piece of graph paper. Look up a second. In our world, and again, this is important because it's going to keep our analysis simple. If you want to put in a marginal revenue curve, and you will at some point, you take the demand curve, you look at where it intersects the x-axis there, and you take the halfway point. That's going to be the point at which you have marginal revenue equal to 0. It's also, as it turns out, the point at which total revenue is going to be a maximum. So total revenue keeps growing as you lower the price until marginal revenue starts getting negative. And then total revenue is actually going to get smaller. In other words, if you go beyond this particular point, let's say you go down to here, look up. So I went down to, I lowered price from P1 to P2, and I went from Q1 to Q2. Everybody with me? Okay? So I lost this, and I gained this. And this is bigger than that, because I'm beyond this point. I'm in the area where marginal revenue is negative. And as long as we're doing nice, uniform graphical analysis, this makes most of the analysis a lot easier. And as you'll see along the way, it's going to tell us a lot about what's going on in a particular marketplace. Because firms are going to operate in different areas of the demand curve based on the sort of corporation they are and based on the sort of market they're dealing with. Any questions yet? It should be, I hope it's straightforward. If it's not straightforward, you'll get straightforward. What else do we have with this? have something that we deal with, and I mentioned yesterday when I was talking about international trade, or Monday, we were talking about gains from trade. Well, for the consumer, gains from trade are something we're going to call consumer surplus. The consumer surplus is simply equal to total use value. That's the total amount the consumers value a particular number of units of this good, minus what they have to pay for it, or minus total revenue. And you'll see, you can do the math. Zero, one, three, six, 2, all I'm doing there to get those is taking total use value and subtracting off total revenue. That's where I got those values. So what can you tell me about consumer surplus? Unlike the position that the firm is in, where the firm has to make some decision, how much am I going to lower my price? Because at some point the firm's going to lower its price if it can. Or if it wants to, and it's going to go, ooh, that's hurting. It's not going to want to do it if it doesn't have to. A consumer always wants a lower price. Because consumer surplus is always going up as price is going down. And you see that in the graph. There's the demand curve. Let's say we're at this particular price. $7, 4 units. Okay, total use value is the area under the curve. It's this and this. Total revenue is this. That's equal to 28 in this case. So what's left over underneath that curve? That's consumer surplus. So we're always going to see consumer surplus as some rendition of the triangle in our models. It's the area underneath the demand curve. It's above the price line. And it's important because it's telling us what the consumer is actually gaining from the transaction. It's neutral about the 28 bucks. If it's values at exactly 28 bucks, it doesn't care. It's sort of the consumer's indifferent. But if it values it at what's the total use value at $34, then the consumer surplus has a lot more value to it than it would be if it were a straight transaction. Questions? Okay. I guess, again, the thing to note is if you're lowering the price, that triangle's always getting bigger. The consumer's getting more of them, and he's getting them at a lower price. So consumer surplus always gets larger than the lower the price, and you can see that on the graph as well. So, in a couple weeks, what I'm going to assume you know how to do is you're going to go ahead, you're going to forget all of this, all of the numbers, because we're not going to see any more numbers anymore, at least in that context. And I'm going to say, okay, you have the demand curve. Quantity per unit of time in dollars, and you have some sort of downward sloping demand curve that looks like that. And from the firm standpoint, you have some sort of midpoint marginal revenue curve that looks like that. And that's the price and quantity that would give the firm the largest total revenue. It's not actually the place where he wants to be, because we don't know what his costs are. But we do know that that's the largest total revenue. And you're also going to be able to tell me, well, if the price rises from there, consumer surplus is going to get smaller. If it lowers from there, consumer surplus is going to get larger. Is there anything else there? So at least in terms of the demand curve that we're going to be dealing with and the sort of graphical pieces we're going to deal with, there are 3 or 4 things you're going to have to be able to see. We don't know at this point what the price is going to be and what the quantity is going to be, because we actually have to put in what the firm does, which is the supply curve. And the supply curve, we've not gone into detail here, but the supply curve is going to be upward sloping instead of downward sloping. And as we'll see later on, it becomes upward sloping because costs are rising. And the area underneath the supply curve is the costs. And that triangle is going to be producer surplus. So we're going to have an analogous piece of graphical equipment to deal with for the firm itself. Everybody okay with this? Okay, a few other little pieces on these curves. So when I draw a demand curve or a supply curve, I'm basically drawing a function. I'm drawing some mathematical relationship between demand and supply. And as you'll see on Friday, this thing can have lots of different shapes, but it's always going to be downward sloping. That's one particular demand curve. And from our perspective, we're going to call this demand. This describes demand. It's downward sloping because it follows something called the law of demand. But this thing can also change. So if I give you some set of conditions for some reason that says demand increased, it's going to mean at some price or some set of prices, the consumer is going to want more than it did before. Or other words, these curves can shift. In this case, they're shifting out because demand would be increasing. They could also shift in. Because demand could be decreasing. And they could also get weird sorts of shapes to them. So you can have them so they look like this to start, and all of a sudden they shift like that. As a matter of fact, if you put percentage taxes on things, that changes demand curves from the axis point to shift. The point of putting this up there at this point is simply, when we're talking about shifts in demand curves, it's going to look like it's going up in the diagonal. I don't want you to think of it those terms. It's moving out from the price line. So at any particular price, you're demanding more of. The same thing is true of supply. On the supply side, you can have a supply curve that happens to be upward sloping. You can have a decrease in supply, or you can have an increase in supply. And we'll go through the reasons you might have them. And their shapes will change. But we'll see policies, and we'll see actions, and we'll see things in the marketplace that are going to cause movement along a curve. So you're going to go from this point to this point. So I'll give you the example we're dealing with now, the gasoline. We're not dealing with necessarily in the United States a shift in demand for gasoline. We're still all demanding at a various set of prices the same various amounts of gasoline. What we are dealing with is a fall in price. So the price has gone from, except in Madison Park, $3.79 to $2.19. Then we're moving, if demand is staying the same, and the only thing that's changing is price, we're moving along this curve. The curve itself hasn't changed. And you need to, most of the bad arguments you see in economics and the media come out of people confusing the distinction between moving along a curve, a function, and actually shifting the function. And we'll spend most of Friday and Monday dealing with the difference between shifts and movements along the curves, but you need to keep those separate. And just so you have the reference point, I'm trying to think of what the 4 reasons were. So oil prices are falling because supply is increasing because the U.S. is producing more oil. So that's an outward shift in supply. If we get expectations, we'll just do the 2 obvious ones. And demand is falling because the Chinese economy is going to hell in a handbasket. So that's an inward shift. So we're ending up with a world glut, at least temporarily. So in that particular case, we're starting out here. So we've got a supply curve and a demand curve. And we're saying, oh, China's demand for oil has fallen. So the whole demand curve's gone down. It's fallen because their economy's just slowed down. And at the same time, the supply of oil has increased because Americans are fracking oil out of North Dakota. So the price is falling. So we're shifting curves in those cases. You end up with a different price and a different quantity. So you can take that sort of, you can read that article and think of it in terms of, oh, these curves are shifting. And we're ending up with a lower price than happened. Okay. Now we get the really ugly one. So the one I'm about to put up there now. We're not going to use for 3 or 4 weeks, but you need to start getting in your head certain components to, I'll give you examples to work on if people feel lost with it. What we just looked at here was the sort of graphical analysis we're going to do when we talk about individual markets. Got a demand curve, we've got a supply curve, and you're going to try to figure out where those 2 curves intersect. That's going to give us some sort of price in the marketplace. And what happens when things change in the market? You get more people. The Food and Drug Administration says that if you drink more milk, you'll live an extra 40 years. All of a sudden, demand shifts out. People drink more milk. What's the impact of that? People demand more. The price is going to rise. You're going to be able to see that stuff in the graphical analysis. Same with the oil analysis. The other world that we're going to be dealing with is how do firms make decisions. And this is a little tedious, but you actually will see some similarity with your grade point average. I'm not implying that if you don't get it, your grade point average is changing, but your grade point average is going to move the same way some cost curves move. And again, you're going to see this today, and you're probably going to see it one other time. We're going to look at cost curves. So we'll start out by saying that there are a set of costs out there. And we're going to call fixed costs. And what we're going to see when we do analysis of firm behavior, we're going to see fixed costs don't change with the level of output. So if you need a building or you need a machine, and the machine can produce 1 or it can produce 100, you still got to buy the machine. There's some fixed costs associated with it. And then you'll have something that's called variable cost. And those costs vary with the level of output. So if you're making bread, you're putting more flour in, you're putting more yeast in, you're using more energy in the oven. The oven's got fixed costs associated with it, the other things have variable costs associated with it. So, I'll try to make this as pleasant as I can. So we're going to produce between, I guess we're going to produce 0 and 9 of these things. Our fixed costs, by definition, never change. So my oven always cost me $10. And that's because I bought it. That's it. My variable costs, on the other hand, by definition, if I don't produce any of them, my variable costs are 0. But as I produce more of them, I add costs on. So variable costs are going up with your level of output. And if you go ahead, I'll have a separate graph for this. Fixed costs look like that. And variable costs look like that. I'm just going up. So if I'm doing this on graph paper, it's going to look like, what does total cost look like? Look up. You just take the fixed costs, or the variable costs in this case, and add it to the fixed costs. It looks like that. So all we did was add this curve to this curve and just shifted it up by $10. That gave us, this is fixed cost, this is variable cost, this is variable cost plus fixed cost equals total cost. And you'll never see that one again either. We don't make decisions based on totals, as it turns out. Okay, now we get into some more of the more interesting pieces. If you look at the total costs here are 10, 15, 17, 50, 22, 50, 30, 52, 50, 67, 50, $85, and $105. So they're always going up. As it turns out, and as you'll see in a few weeks, firms don't make any decisions based on total fixed costs, total variable costs, or total costs themselves. They make decisions based upon average total cost, average variable cost, and something called marginal cost. Average total cost is exactly what you think it is. It's total cost divided by quantity. Average variable cost is the variable cost divided by quantity. And marginal cost equals the change in total cost. If you haven't seen this before, I'll use delta to mean change all the time. I'm going to throw these numbers up here. I recommend both of you make a clean table of them, and I'm going to do a sort of a standard graph of them. If you're the tiniest bit uncomfortable for how these things look when I graph them, you should go ahead and graph them. Get a piece of graph paper and actually do it. I'm not going to try and do it right here. So, let's see, average total cost. $15, $8.75, $7.50, $7.50, $8, $8.75, $9.64, $10.63, $11.67. And average variable cost is $29.5, $3.75, and marginal cost is $2.50, $7.50, and $12.50, $15, and $3. So what do you see with average total cost, average variable cost, and marginal cost? We make the assumption, which is a fairly safe assumption looking at production functions, that if you actually look at the way firms operate, you'll see as they start to produce, the more they produce, they get something called economies of scale. The costs actually fall to start with. So, and it's just a matter of, instead of making 1 loaf of bread, you make 10 loaves of bread and you only have to hire 1 person. So costs are actually falling. At some point, that's no longer true. Your costs are going to have to start to rise. So that's why we see average total costs fall to here, they level off, and then they start to rise. Same thing with average variable costs, same thing with marginal costs. Okay. That's going to be our standard model. But what that gives you is here's output, there's dollars on this axis. These curves are always going to look like that. You're going to have average fixed cost curves that look like this. Does anybody know what that means? What? Who's a math major? What is that? Fixed costs are asymptotic to the origin. So they're always declining. Average fixed costs, but you're always dividing by a bigger number. You don't need to know that. But fixed costs are always declining. They're always going to have, they're always just, you're dividing by a bigger number all the time. So average fixed costs look like that. Average variable cost looks something like that. Okay. Average total costs, by coincidence, are going to equal average fixed cost plus average variable cost. So they're going to look like this. Look up a sec. And the distance between these two is just going to be the fixed cost. So we're always having some bottom on these two, average variable cost and average total cost. And the last thing that's always going to be true is this marginal cost curve. The marginal cost curve is going to go through the minimum of the average variable cost curve and the minimum of the average total cost curve. And you want to remember that when you draw. It has implications later on. But at least for now, I want you to have the general idea. You're not going to get all this in today. It goes through the minimum of the average cost curve. So the way to think about it is this. If your grade point average is 3.5, and you get a marginal grade that's less than 3.5, what's going to happen to your GPA?
Drops.
It's going to go down. So if marginal costs anywhere in here are less than your average is going to be falling. As soon as your marginal gets above the average, your GPA starts to go up. So the cost curves are working the same way. So if the margin is above the average, costs are rising. If the margin is below the average, costs are falling. That's all that you're seeing here. I guess the other thing to keep in mind here, and we won't do anything more with this right now. Well, we can. So if you want to get total costs out of that graph that we're dealing with now, with the little curves on it, how do you do it? So 6 on average costs that much, right? Costs this many dollars. That's the average, whatever that happens to be. Is everybody with me on that? Okay, so total cost is actually, it's just average total cost times the quantity is by definition the total. You're just switching it around. I'm not sure if we use that much of it. We're going to fill in some of it. Okay, let's stop here on this stuff. The first part of what we did, which is the developing demand curves and shifting demand curves around, and ultimately supply curves. We'll start doing that on Friday. This stuff we won't see for weeks. I do want you to at least know that it's coming if you're uncomfortable with it. And you should go ahead and try it out. If you, again, go ahead and graph it if you need to graph it. If you get totally stuck after you graph it, come to me and I'll give you 3 or 4 more and you can graph them some more. It sounds like a fun Friday night. These are the sorts of, the 2 sets of graph analysis we just put up there are 90% of the, we need to figure out how they're shifting around, the prices, what happens when policy changes, all that sort of stuff. Take a 5-minute break and then we're going to do a little capital theory. Great for that.
I forgot about those. Yeah.
Actually, no, lost it. it on the air.
We've gone through it so much.
Stand back as a number. I can read out. Like voice, you see things. Cool as you are. Well, pretty good. What's their face? Yes, that's what I know. That's what I see. Go have classes. Like everybody.
So, almost always gets skipped over in introductory and intermediate micro classes is how do you put time component to all of our analysis? In other words, we look at things as though you consume everything today, or that price reflects consumption in today's terms instead of something over time. And one of the questions that always has to be asked is how does time affect all this analysis? And what we're going to do, and one of the things I really do want you to get out of this course, so you're going to be a bloody genius when it comes to just general microeconomics when you're done with the course, but you'll also have something practical. And the practical part of it is, I want you to learn some capital theory. And what capital theory is how do all these prices get determined? And how do mortgage payments get determined? And how do interest rates affect mortgage payments? And how does the length of time affect mortgage payments? And what's an annuity? Which is another form of asset here. An annuity pays you a stream of income over time. How do the prices of annuities get determined? Almost everything that we deal with, actually I should warn you, you should go to a separate part of your notebook for this, because I'm going to maybe ask you one question on a test, but most of the time I'm just going to try to drill it into your heads. So all this capital theory stuff is basically going to be inside. So I guess the best way to start is do this by hand. I Okay, if I offer you, so I'm gonna offer you $100, it's 2015. I'm gonna offer you $1,000 a year from now, or $1,000 today. Is anybody out there gonna take $1,000 a year from now? No, you're all gonna take $1,000 today. Okay, that's a good start. How about $1,000 today, or $1,100 a year from now? So 10% more. Anybody gonna take the $1,100 a year from now? So we got one person, 2 people, 3 people, 4 people, 5 people. So I'm just looking at these marginal decision makers here. I guarantee you, there's somebody in this classroom I'm gonna offer $10,000 to a year from now, and they're gonna go, nope, I want $1,000 today. Okay, how many would take, instead of $1,000 today, $1,200 a year from now? Okay, if you want some of the same hands, $1,300, $1,500. Is there anybody that would not take $1,500? Good, there's somebody in here that's on the fast side. So, what you're all exhibiting is some value of time. You want to consume stuff today, as opposed to, or at least you want the decision-making process to be able to occur today, as opposed to a year from now. And you're willing to pay a price for that. But there's some price at which you say, no, I'm not willing to pay that. I'll forego consumption for a year and wait for a year to get this money. You're actually showing your own particular personal interest rate when you do that. So what we're going to be doing as we develop capital theory is not so much go through and try to figure out what your particular interest rate happens to be. Well, I'll tell you this, I can do that with a group. It's interesting. You do it with a group of, pick the optimal age, about 60, 65-year-old people, and they're really conservative. You know, you say, oh, they'll take $1,050 next year as opposed to $1,000 today. And then you boost up to about 75, and it starts to shift. And you go, oh, what? All of a sudden they're turning it down. And what you're realizing is that they're realizing they're going to die. And they're going, I'm not taking that chance. My time preference has just changed entirely. And you can see it in the room. You can see the age groups sort of shift this time preference for money. But the interesting part is that 15-year-olds and 85-year-olds have about the same time preference. They want it today. And it's not that the 15-year-olds think they're going to die, but you offer them $1,000 and they want it today. So these things, you know, like all other prices, these prices can change over time. So we're going to start, and I won't go through all the ghastly pieces today, but so you're sitting here, I know you're not suffering through this class because this class is a delight, but you're suffering through 4 years of miserable classes, and you're paying money to do it. Okay? What's the cost to you of doing that? Certainly it's the tuition. That's the most obvious one, which is not inconsequential. What else is it? Effort? Yeah, what else?
Time.
What do you mean by time?
Time to do the classes, how long the classes are, the time added up.
Okay, what else? what else in a more economic sense?
4 years we could be working and earning money.
Yeah, you could be earning money for 4 years doing something else. So you're basically sitting here going, I'm going to forego this income, presumably because you think you're going to get higher income over after 4 years, and hopefully you do. Actually, the statistics say you do. But that income that's going to be higher income isn't going to come for 4 years. You're giving up income that's available today. If your dad owns a plumbing company, you're sitting in this room may be a bad decision, because you could be out there making $70 an hour in 2 or 3 years. And of course, those things are changing over time. But you are making that decision based on the fact that you're looking at a future value of income, or something we're going to call future value. There's some stream of income that you're going to get starting 4 years from now. Or if you're going to go to medical school, it's going to be 15 years from now. Or if you're going to get a PhD in economics, it's going to be 9 years from now. But you're foregoing that income, which has value to that. Because remember, you could be making that income, taking some of it off, earning money with it. You're earning what you could earn on the money. You could be buying stocks with it, or buying real estate, or whatever it might be. Those foregone earnings. And then this income that you're getting 10 years from now, because it's higher income, isn't really worth as much. And when you want to figure out what's this degree actually worth, you have to bring back all these future values into some sort of present value and be able to say, well, look, in present value terms, I'm going to make so many dollars over my lifetime with a high school degree versus a college degree versus a master's degree versus a medical doctor degree, etc. And you do that by, you look at something we're going to call present value and something we're going to call future value. And what present value and future value do is adjust for the time element and adjust for the price you pay for time, which is this interest component that we're dealing with. All of these things, so stocks, bonds, the houses you buy or you rent, durable goods, which we'll describe here as refrigerators, but there's a whole separate category that's got by Feds that's durable goods, automobiles, lottery winnings. So what do we know about lottery? What is it that they do when they do lottery winnings? So you win a lottery, and it says, okay, you won $1 million. Well, what you actually won was, you won so many dollars a year for the next 20 years, and if you added up each of your 20 payments, you get $1 million. So you get $50,000 a year for 20 years. But what else will the lottery people do for you? They won't give you $1 million, but what will they give you? They'll give you like $373,000. And the reason they give you $373,000 is because you can take that $373,000 and invest it somewhere at 5% or 6% or whatever you're going to invest it at. And at the end of 20 years, everybody's guessing you're going to have $1 million in the bank. This $373,000 that you're willing to take, and maybe you're not willing to take, some people are and some people aren't, is the present, called the present value of that stream of income that you want, at $50,000 a year. That's what present value is. It takes these future streams of income, and it could be costs as well. We're looking at income right now. It takes future streams of income and puts a value on them today. And that value has some interest rate component associated with it. And it may seem a little odd to be looking at this early in the course, that you're saying, why are we looking at capital theory already? We really haven't talked about some of the fundamental things that are supply and demand and things like that. And the reason is in a realistic world, most of what you're hearing about and most of what your purchases deal with have some component of capital theory in them. And what we'll start doing, every week we'll do pieces of this. I'll start feeding you pieces of information. We'll start by figuring out what are future values. So you want to know the future value of $100 1 year from now at 6% interest. That's 100 times 1.06 is equal to $106. So that's, we'll come back to the formulas later. That's sort of the basis of the whole thing. And I'm hoping that after 6 or 7 weeks of this, you understand the concepts. I no longer write out these things. I go to Google and I look up annuity calculator or present value calculator and I plug in a bunch of numbers and it gives me the answer. But you need to know what the pieces are before you can say, oh, this is why the mortgages are good right now. This is why mortgages are going to change. And this is why deflation might be bad in Europe. It's because these present values are changing all the time. So we'll stop here. We're going to start doing pieces of this. I will give you handouts and small problems. And I'm hoping that by the end of the quarter, it's sort of second nature. If your name is not called, you need to come up and do your name. Put your email address in this sheet. I'll see you Friday. It's really much friends.